One of the easiest sorts of things that we can do to determine if a relation is a function or not is we can use something called the vertical line test. And the vertical line test essentially is exactly what it says, is that you look at the graph of a relation, you draw many vertical lines, and if any of those vertical lines intersect the function at more than one point, that means it is not a function, it's just a relation. But if we draw a bunch of vertical lines and it only intersects at one point in each of those, then that means that it is a function. So let's take a look at four graphs and let's determine whether or not that the graphs represent a function or not. And we're going to use the vertical line test. So this is actually really easy. So we draw vertical lines, a whole bunch of them, and we notice that for this relation, all the vertical lines intersect at exactly one point. And so for this first graph, we would say, yes, it is going to be a function. However, we can draw a bunch of vertical lines and all it takes is one, but we notice that when we draw a vertical line through that sort of that sideways U shape, that's going to turn into having 2 points of intersection at least. And so we're going to say that that is not a function. Okay. Similarly, for the one directly below it, all right, if we drew a bunch of vertical lines, at any of those, pretty much, we could just go ahead and say no. The trickiest one is going to be this animal right here, especially like sort of in the middle here. So you have to be really careful when we draw vertical lines. All right, so if we draw vertical lines, and I know that wasn't a good one, so let me erase that. But if we draw vertical lines, all right, and although it's a little bit tough to see, all right, we notice that every time we draw a vertical line, it only intersects the graph of the relation at exactly one point. And so this one, although tougher to see, is indeed going to be a function. All right, so that's all you have to do to determine if the graph of a relation is going to be a function or not. Use this vertical line test. Another exercise is looking at the graphs of functions and being able to find indicated values. And essentially what that means is that you're just lining up points and being able to find them. So we have this sort of function here, and it is a function because it would pass the vertical line test. And so what we're going to do is we're going to find what happens at f at -2. Now, what that means is that we're going to look at where x is going to be -2, which is right here. And we're just going to line it up. And we notice that the point right here is going to be -2, -3. And so what that means is that when f is equal, or x is equal to -2, the output is going to be -3. Because remember that f at x is the same thing as y. Okay, so basically we're just looking for the y value in the graph. F at 2, if we go to 2 on the graph, which is right here, we just go and trace it up, and it's going to be right about here, and it looks like it's going to be 4. So f at 2 is going to be 4 because this is the point 2 comma 4. So that's all you have to do is be able to find the indicated value from the graph of a function. Is you just go to the x value and you just go through and just try to find the y coordinate. In this example, we're looking for when x is equal to 3. So we go to 3, and then we just go right here on the function, and it looks like that it's going to trace over to the value 1, because this would be the 0.31, and so f at 3 is going to be equal to 1. Nice and easy. Okay, there's a couple more, and you might want to, or this one right here, so you might want to try this one just to make sure that you're okay doing it on your own. So maybe pause the video, try to do it yourself, and then unpause the video. F at -1, we're going to go over to -1, and then we're going to go up here, and it looks like that's going to be the point -1, 2. And so f at -1 is going to be equal to 2. And then finally 3, right here, we go up here, and it looks like that's going to be the point or the coordinate, the ordered pair 3, 4. So that means that f at 3 is going to be equal to 4. So nice and easy, right? All we have to do is just line those up. So vertical line test and being able to find where the function's value is given the graph of the function are really easy. Okay, we wish the entire course was like this. Unfortunately, it's not going to be. It will be more difficult. So one concept or one idea is that we're going to tie everything together that we've seen so far with the graphs of functions. Because we've talked about domain, we talked about range, We talked about intercepts in the previous section, and we certainly were just looked at the indicated values of functions. All right, so let's first of all start with the domain of the function. Now remember, domain is all possible x values. And remember that the range is going to be all the y values. All right, so for letter A, if I'm looking at the domain of this function, now we take a look at these arrows, and these arrows mean that it's going to keep going this way forever. Okay, and notice that the x value is going to keep going to the right and it's going to keep going to the left no matter what. Okay, so that means that if I were to keep drawing this forever, all right, and remember this is just going to keep going, that the domain for this is going to be that x is going to be in all real numbers or from negative infinity to positive infinity. All right, so that's a way that we can write the domain in that interval notation. Right? Now, if I was to look at the range, that's going to be where we go from the lowest possible value to the highest possible value. And notice it keeps going down. So if it keeps going down, that means that the lowest possible number is going to be negative infinity. And then we're going to trace this up. And if we keep tracing it up, it's not going to go to infinity on this graph. It's actually going to stop at a specific value. So we keep tracing it up and up and up. And the highest possible number that it gets to in the y direction, all right? Because remember, the range represents the y values, is going to be 4. Now, it includes 4, all right? So when we say inclusive, remember that we're going to write a bracket, okay? So that means whenever we see the bracket, that means it includes that value, okay? So, and with infinity, we never write a bracket. We always write a parenthesis with infinity no matter what, because we don't know what infinity is. It's a theoretical concept, and so we can't include it. So next thing we're going to do is we're going to find the intercepts of this function. All right, remember, x-intercepts and y-intercepts are basically where it crosses the axes. All right, so let me erase this for a second. And if we look at this, the x-intercepts are where it's going to cross. And so two ways that we can write the x-intercepts for this. One of which is we can say that the x-intercepts occur at -3 and 1. And we could write that as like a set because it is a set of values. Or we can write it as ordered pairs. Now remember, at the x-intercept, the y value is always 0. And so the two ordered pairs for the x-intercepts are going to be -3, 0 and 1, 0. Okay, or another way we can write it is in this set notation. For the y-intercept, the only place it's going to cross the axis is right there at 3. And so two ways that we can write the y-intercept. We can say that the y-intercept is going to be equal to 3, or we can say the point 0.03, because remember with the y-intercept, x is always going to be equal to 0 for y-intercept. Okay, so these are important concepts, and I know I keep saying them throughout the videos because they are going to keep coming back to us throughout the entire course. Last thing we need to do, we just need to find the indicated values. So we just need to find f at 1 and f at -1. And so just like we did in the previous exercise, we go to -1 and we just trace it. And it looks like right here that we have this point, which is going to be the point -1, 4. And so that means that f at -1 is going to be equal to 4. And that's just because the point -1, 4 is on the graph. If we go for +1, that's right here. And it looks like that the point is going to be 0, 1 for this. Or sorry, 1, 0, because we go to the right one and we don't fill up any. So finally, we say f at 1 is going to be equal to 0. And that's just because 1, 0 is the point. And remember, we had that already with the intercept. All right, so hopefully this is helpful for you guys to be able to look at a graph to be able to find domain, range, intercepts, and then any indicated value. Okay, so in our final video in this segment, we're going to take a look at just a few more examples of doing all of this for several different graphs, so that way we can get a variety of these sorts of things. So that way we just don't look at one of these and we kind of understand how this works for several functions.